Yes, very good morning, students. So, in earlier class, we discussed about the introduction to thyristor control drives. So, in this, what is the drive? What is the electrical drive? What is the block diagram of an electrical drive? And what are the various parts of an electrical drive? And describing the each and every part in the electrical drive. Yes. So, in today's class, we are going to be start the actual DC drives. So let us see here. Yes. So far what the details discussed belongs to the power semiconductor drives. Those all are the introductory part belongs to the power semiconductor drives. So now onwards the original DC drives are commenced. So let us start how the DC drives are classified, why these DC drives are essential. Everything is going to be discussed here. Yes. Yes. Already we discussed that in olden days, particularly when variable speed drives are required, directly we approach the DC drives. The speed control of DC drives are very good and very accurate. So that is the reason for variable speed drives, DC drives are to be preferable because of the continuous variable voltage available in the armature control method. Yes. So due to their ability to supply a continuous variable DC voltage, controlled rectifiers and DC choppers can make a revolution in modern industrial control equipment and variable speed drives. Yes. So there are two major controllers. One is the rectifiers, converters. One is the rectifiers, another one is choppers. Yes. So a rectifier does AC into DC, a chopper does a DC into DC. Yes. So those two are having an ability to give a continuous variable DC voltage. This continuous variable DC voltage will change the speed of the DC motors. Those two are made a great revolution in modern industrial control equipment as well as the variable speed drives. Yes. So the DC drives are classified. See here. The DC drives are classified according to the coordinate operation. Yes. So there are, suppose if you draw the coordinate between voltage and current, it has a 4 operations. And if you draw the same characteristics between speed and torque, it is also gives the 4 coordinate of forward motoring, forward braking, reverse motoring, reverse braking, like this. The 4 coordinate operation. Yes. So DC drives are classified according to the coordinate operation. No doubt in this. So these are 3 types. So what are those? Single phase drives. So in single phase, semi-control as well as the fully controlled drives. 3-phase drives. In 3-phase also again semi-controlled and fully controlled drives. And chopper control drives. Chopper control drives. Yes. So these 3 drives are mainly focused in the DC drives, such as the single phase drives, 3-phase drives, and chopper control drives. So single phase and 3-phase drives are analyzed in the first and second units, whereas chopper control drives are analyzed in the third unit. Yes. So let us take the one by one, and going to be discussed the semi-controlled converter as well as the fully controlled converter, how it controls the operation of a DC drive. In this regards, the case 1 or first one is the single phase semi-controlled converter pad DC separately excited drive. Single phase semi-controlled converter pad DC separately excited drive. Yes. So see, first of all, as per the heading, you have to draw the drive circuit. Yes. So the single phase semi-converter feeds an armature circuit and its coordinate operation as shown. Yes. See here, this is the drive circuit. This is the drive circuit. So the name itself, what is the supply? Single phase supply. What is the converter? Semi-control converter. And what is the drive? Separately excited. So motor is so as per the basic block diagram of an electrical drive, source is a single phase AC supply and power modulator is a rectifier, semi-control converter or single phase semi-control rectifier, and drive is a DC separately excited motor. Drive is a DC separately excited motor. So it is simply a open loop drives. So the single phase semi converter feeds the armature circuit and its coordinate operation action. So this is the single phase semi control converter by DC separately excited drive. So why this circuit? In the sense, this is a field circuit. It is a field circuit. Yes. So you see here the single phase supply. It is as usually phase and neutral. It is a AC supply, single phase AC 50H supply. So this is a bridge form. Bridge type, 2 arms are there, each arm consisting of two switches. Yes. So this is the first arm, this is the second arm, where T1, T2 are the control switches, D1 and D2 are the uncontrolled switches. That is the reason it is known as a semi-controlled converter. Yes. So the supply voltage is given to the single phase semi-controlled rectifier. So AC is converted into DC and the converted DC is fed to the separately excited motor armature. Yes. So here there is a prevailing diode. The importance of the prevailing diode I will discuss later. Yes. So here, is there any parameter which was unknown for us? No, all the parameters are very clear. Vs is the source voltage, Is is the source current, T1, T2 are the control switches, D1, D2 are the uncontrolled switches, and DFW, this is the prevailing diode which carries the current, that is the prevailing current ID. Yes. So this is the armature current which is coming from the source to the motor, and A1 and A2 are the armature terminals, and this one is the armature resistance and armature inductance, and this one is the motor. Yes. So for separately excited motor, the field is also supplied with a controlled converter. Why? Because so if field is directly given to the supply, what will happen? A fixed field current will be available and only one flux is possible for us. So one flux will give only one speed in the field control. Suppose if you control the field circuit, if you supply the field circuit through a converter, so based upon the firing angle variation, there may be a different field currents you can achieve, so that different flux are so that both armature control is possible with help of this converter, field control is also possible with help of this converter. Clear? Yes. So as per the field supply, this converter is operated, and then the field current is passing through the F1, F2 circuit, so that the field circuit will produce the flux. Yes. So this is the circuit diagram, and this one is a coordinate operation. Coordinate operation in the sense, so based upon the output characteristics, output parameters, voltage and current. So this drive always, it is a semi-control converter. So as long as the supply is excited, the power is always passing from source to the load only. So at the output of the motor, you can analyze the voltage and current. Both are always positive. Yes. So therefore, the product of power is in positive. That may be possible in the first coordinate only. Is it or not? Yes. So you see here, all these parameters, output, average output voltage, average output current, all parameters, IF field current, LF field inductance, RF field resistance, F1, F2 is the field terminals, Vs is the source voltage for the field circuit, like that. All the parameters are described here, and principle of operation is going to be explained in the next slide. Yes. So actually the operation of the drive is to be explained in two modes. One is the continuous mode of operation, another one is the discontinuous mode of operation. Okay. So as per the undergraduate student, the discontinuous conduction is not involved in our syllabus. Only continuous conduction is to be involved. So let us start the operation in continuous conduction mode. Yes. So the operation is to be explained in continuous conduction mode. Before that, you maybe write a small description belongs to this circuit after the circuit. Yes. So what is the description? The single phase semi-control converter fed DC separately excited motor as shown. And its coordinate operation is also here. And the armature is excited by a semi-control converter having T1, T2 control switches and D1, D2 uncontrolled switches. Clear? And the field is also excited by a control converter. When field control is required, the control converter is used. Otherwise, you can directly give to the field supply. Yes. So field control is essential. You can go for the field controller. Otherwise, there is no need of field control. You can directly go to the system so that only a single field current will be available to the circuit. Yes. So this description, at least you have to be describe about the circuit, what the circuit is having. So T1, D1 is operates from the positive half cycle. T2, D2 is operate for the negative half cycle. All these details you have to be described as a description of the circuit. Yes. So how you can write the description? The single phase semi-control converter fed DC separately excited motor as shown. The armature is feeding the single phase semi-control converter having a switches T1, T2 as a control switches, D1, D2 as uncontrolled switches. Yes. So the field circuit is excited by an external converter. When field control is required, this converter is used. If field control is not required, there is no need of any converters. Yes. So this is the description of the supply. Yes. So let the supply voltage defined as Vs is equal to Vm sin omega.